Hello students, in this video I am going to explain you meter bridge. It is an arrangement in which unknown resistance can be calculated. You can see here there is a galvanometer, a resistance box which are connected to the meter bridge, and this is a jockey. Jockey is used to slide on the bridge wire. This is the bridge wire. It is a metal rod with one end as knife edge and is used to find the balanced position on the wire, or you can say that it is slided along the wire until the galvanometer shows null deflection or zero deflection. And this is the wire or the conductor whose resistance we have to calculate. Let us start. It is based on the principle of Wheatstonebridge and is very sensitive device for the measurement of unknown resistance. This is the simplified circuit diagram of the meter bridge. Here 1 meter long wire AC made of manganese or constantan having uniform cross section throughout is fixed along a scale on the wooden base. So here is a scale along AC and the ends A and C are joined to two L-shaped copper strips, these L-shaped copper strips, and consisting of binding screws. These are the binding screws. There is a third copper strip having 3 binding screws like this. On the middle of this copper strip, a binding screw consists of jockey and galvanometer. This is the galvanometer and here the jockey is connected. And the function of the jockey is to slide on the wire AC and search for the null point or zero deflection in the galvanometer. At that position, the bridge is in the balanced state and we can calculate the value of the unknown resistance. Here we have taken X as the unknown resistance and R is the known resistance from the resistance box. Let the position at which the jockey is touching the wire AC and has obtained null deflection on the galvanometer. At that position, the length AB is marked as or noted as L. The leftover portion of the wire AC is here now BC and it is 100 minus L centimeters because we have taken 1 meter. Let the unknown resistance represented as X only. So we can calculate the resistance of wire AB as P is equal to rho L upon A, where A is the area of cross section of the wire and rho is the specific resistance of the material of the wire, and that is known to us. Now resistance across BC can be calculated as rho into the length of BC wire, here it is 100 minus L upon area, that is A only. Dividing the two equations 1 and 2, we have obtained P upon Q is equal to L upon 100 minus L. Now according to the principle of Wheatstonebridge, we are aware in the balanced state it is P upon Q is equal to R upon X. So using this balanced state condition in equation number 3, we get this, that is R upon X is equal to L upon 100 minus L. Therefore the unknown resistance can be calculated as R into 100 minus L upon L. In this experiment, the resistances of the copper strips and the connecting screws are not considered. We have omitted them. So these resistances are called as end resistances. Therefore, if we need to calculate very small resistance accurately, we cannot use meter bridge. Also, the current should not flow through the meter wire for a long time. Otherwise, the wire will become hot and then definitely the resistance will get changed. Now let us practice one numerical. This is the meter bridge and it is given in the question that the balance point is found to be at 39.5 centimeters from end A. That is, this L is given to us as 39.5 centimeters. So definitely we can calculate the length from B to C, that is 100 minus L. When the resistance in the right arm is 12.5, here in this question X is given to you, that is 12.5 ohms. We need to calculate the value of R. So simply by applying the balanced state of the Wheatstonebridge, that is P upon Q is equal to R upon X, or by applying the meter bridge formula, R upon X, that is 12.5 ohm, is equal to L upon 100 minus L, that is from the B to C. We have calculated the unknown resistance R as 8.16 ohm. Let us see one more numerical. In this meter bridge, the balance point is found to be 40 centimeters from end A. That means from A to B, the length L is given to you as 40 centimeters. If a resistance of 10 ohm is connected in series with R, balance point is obtained at 60 centimeters from A. So we have to calculate the values of R and X both. So there are two cases. In the first case, it has been told that L is equal to 40. So if L is equal to 40, we can calculate 100 minus L as 60 centimeters. So we have used that is R upon X is equal to L upon 100 minus L. We have put down the values and find out a relationship between R and X. Let us mark it as equation number 1. The second part of the same question says that now a 10 ohm is connected in series with R. That means in the second case there is one more resistance in series with R, that is there is one more resistance here. And the value of this resistance is given to you as 10 ohm. Now this combination will act together for the resistance between A and D, this position. So this will be the series combination of R and 10 ohm. So it can be written as R plus 10. Again the balance state, R plus 10 upon X is equal to length between A and B, and that is here given as 60 centimeters. So it will be 60 in the numerator, and 100 minus L will come out to be 40, that will be in the denominator. Rearranging the equations, we have obtained equation number 2. Now let us solve equation number 1 and equation number 2. So we have obtained X is equal to 12 ohm. Putting this value of X in the equation number 1, we have obtained R as 8 ohm. So the unknown value of the resistances R and X are 8 ohm and 12 ohm respectively. Thanks for watching. Please like, share and subscribe.